Greetings everyone. My name is Pallav Jyoti Buragoy and my registration number is 20BC0866. So, the topic for my blockchain assignment is Easychain. Easychain is a simple blockchain which is implemented using Python. So let's get started. What is a blockchain? You can see the structure here. A blockchain is a distributed digital ledger technology that allows secure and transparent storage and transfer of data without the need for a trusted central authority. It consists of a chain of blocks, each containing a set of transactions or data which are cryptographically linked and secured using advanced cryptographic algorithms such as hashing and digital signatures. Once a block is added to the blockchain, it cannot be altered without the consensus from the network participants, making it a tamper-proof and immutable record of all the transactions that have occurred on the network. The technology has gained widespread interest and application in a various variety of domains, including finance, supply chain, management, healthcare, and more. So here you can see the blockchains. Here are the blocks, and these are what they contains. The header blocks, then address, timestamp, nonce, and worker root. About this implementation, this implementation is limited to the hash ledger notion. It expressly excludes the concept of mining or any other of distributed consensus. It also reduces the scope of blockchain to a cryptographic primitive rather than a mechanism of distributed consensus by abstracting the concept of a transaction to that of a message in general. The header and the payload concepts using messages and blocks are borrowed from Bitcoin. So as you can see, this project it is a simplified version of the proper blockchain, which is used in full-fledged cryptocurrencies. Conceptually, it works somewhat like this image from Satoshi Nakamoto's original Bitcoin paper. So it's the image. Let me also open this paper. As you can see, this is the paper. This is the whole paper by Satoshi Nakamoto, the creator of Bitcoin. Now let's move on to some more concepts which are included in here. As you can see, it contains messages and blocks. What is a message? A message has a data, an optional sender and receiver, and metadata, which is append data size, hashed together for integrity. Messages have headers and payloads. Sections are handled and hashed independently. At message creation, the payload is populated and hashed. After being added to a block, the header is finalized and the message is hashed. The block will seal, validate, and link messages by supplying the current message's brief hash field with the last message's hash, unless it is the first message. Seal calculates the message's hash from its payload and previous hash values. The block automatically links and seals messages. Recalculating hashes will reveal any message manipulation. Validating the message, the block verifies the previous hash noted. What are blocks? Blocks are chains of message objects. Each message's previous hash field is updated with the block's last hash. The block is linked to the previous blocks, sealed and confirmed once no additional messages are added. Sealing messages the most recent message hash, the block's previous hash, and the current timestamp. As message chaining includes all preceding messages in the block, it is the most recent message hash needed. After sealing, the block hash is recomputed and compared to expected to identify the validate calls validates on each message in sequence to verify block integrity. The blockchain verifies interblock linkages. Let's go to the coding part. Yeah. This is the main code. So as you can see, it imports some libraries, including a pickle library. Pickle is basically a library which, as you can see here, it's a library which implements binary protocols for serializing and deserializing a Python object structure. So here, This is the blockchain library which is we created here. So in the first part, you can see a block B1 is created, and messages. These things are added. These are the messages, and it is sealed. Now for the block two, again the same message means the different messages are added and sealed. B3 added and sealed. B4 same added and sealed. So here uh, we initialize the chain and we include all these blocks we created to the chain. Here we we validate the chain. Here and for the next code, we dump this chain into this chain.p file, which can be created when we run the code. So I already that's it. So this is deserializing and validating. This is serializing for tampering. This is hostile tampering, and this is the tempered blocks message. This is the this message. As you can see, the original message was this one in B3 block, and we tampered this message. So blocks two means the third block, and we tampered this message by inputting a different string inside that. So like that, and we did the validation thing again here. So let's check out the this blockchain file what it contains. So this is the blockchain .py file contains. So we imported hash lib and time. So hash lib is basically the it contains very many hash functions. So it can be used to secure hash and message digest and use message digest algorithms. Contains some popular hashes like these things 1 to 24 to 56 and all. So so we have created a class message here. This is we can get payload hash by this SHA-256 algorithm on this thing. And in the second one, you can get a message hash again using the SHA-256 algorithm. So and this is the link function. So it links the previous hash. Means not sorry, not the previous hash, the current hash to the to the previous block. This is the seal. It sees the message. This is the validate message. So it compares these things: self payload hash and self get payload hash. This is the hash we have and the hash we can get after hashing the thing. This is the class of the block. A constructor again here. This is the get block hash. So it gives the hash of the block using SH256. Add message. It will add a message and then seal and validate. A link again the linking thing. Previous hash to the block hash. A seal which seals it seals the hash. So this is a validate function. So it validates each message, then chain integrity, and then the block hash. So you can see mm, yes, it compares these hashes and all to validate. Now, so it also uses throw invalid blocks since an invalid message invalidates the whole block. Okay. So next, let's go to the blockchain class. So in this blockchain class, you can see again a constructor. This is the add block thing. Add block to the blockchain. The blocks are created here. Add block. So it again adds the blocks. This is the validate thing. Again, a validation function. So it validates it's correct or not. Validate each block in order. And here are some invalid exceptions. These are used in case of errors. So let's get to the other codes which contains some testing files. So basically, this we can use this codes in blockchain. So for this case, codes use this unit test module, which we can see here. Here. It's a basic concept of testing. You can see this is the test block. So it tests the is testing the block. So this code defines a set of unit tests for the blockchain implementation. The implementation includes two classes: messages and block. Messages represents a message in the blockchain, and its properties is the data sender receiver timestamp and hash. Block represents the block in the blockchain and consists of a list of message objects. So this is a blockchain testing code. So this code defines a set of unit tests for blockchain implementation using the Python. The tests are written using unit test model and again unit test model. So the tests focus on different aspects of the blockchain implementation, such as creating a new blockchain, adding blocks to the blockchain, and validating the integrity of the blockchain. So I'm going to cover it. The test is various methods to create blocks and chains of blocks with messages, and then check the blocks and chains are constructed correctly. It contains a test blockchain class. The next code is class test message dot py. So this code contains a series of unit tests for Python implementation of blockchain message class. So the message class, as you know, we already went through. The test ensures that message class behaves as expectedly by testing various scenarios, such as creating a message with or without sender receiver, tampering with the message, sealing the message, linking messages, and validating messages. The tests use the Python unit test module again. So if the test pass, it means that the implementation of message class is correct and it can be used in a blockchain implementation. So let's go through quick over the function inside this test. This is get messages, block hash, payload hash, some hashing functions, and these are some more functions. Testing, these are basically the testing functions, which test different things like add message appending and all, sealing and all. This tests everything. In this case, so in the blockchain, you can get this get blocks, get blocks function. There's some testing functions, more testing functions and all. In this test message, we can get this testing functions like payload hash, message hash, uh, and these are testing functions again, which is do the testing. So basically, the test message is longer, means code is longer in this file. Let's run it in quick. Okay, so we got this output, and we can also find that it creates a file name called chain.p outside my means my folder. So you can say this is a chain.p file. It creates due to that Python pickle model. Here you can see it creates a Python pickle model chain. And let's quickly run also this message also this test message also to see. Obviously, these are not related to this things, as you can see there is no relation, but you can use them. So here you can see seven tests done, seven again, four tests done in this time. Yes, 11 tests done. As you can see, this is the largest one there has been removed. These are so besides basically to test the blockchain and message part. And here we have the blockchain class contains the basics like how means the message functions, the blockchain functions, the block functions to create and create and link everything. And this is our this is the driver means mean code driver code. So where we can do everything like this and everything.